the proof of the two formulas. So the first one is this one. So the simplest way to get it, simplest ever that I found, is to start by the following. So actually it's proof this, and then the proof is here. You start by saying Sn, which is sum of all terms until a certain position, is the same as T1 plus T2 plus T3 plus T4 plus T5 until Tn. Correct? Whether Tn is T17 doesn't matter, because n can be any position. You understand that? Right? And then, so, bro, the next thing you do, you simplify this. So I can say Sn. So there are two ways you can simplify it. You can find T1, meaning you can go and have something like, you know, Tn equals to A plus D into n minus 1, right? Again, you can find you can go and find T1. You can go and say T1 is the same as A. I don't know A. I don't know D. But one thing I know is that the position is 1. And 1 minus 1 is 0. Means this cancels. That means T1 equals to. You see that? And it's true. A is the first term. And then you can go to T2. T2 is A plus D into 2 minus 1. And this is the same as what? This is the same as T2 being equal to A plus 2 minus 1 is 1. So it's the same as T. So T1 is A. T2 is A plus D. This is T2. And T3 will be A plus 2D. A plus 3D. A plus 4D, and so on. But I don't need all of them. I need the last one. The last one is Tn, which will be A plus D into n minus 1. Because that is Tn. You get what I'm saying? Then if someone wanted the previous one before this one, it will be Tn minus 1, which will be A plus D into n minus 1 minus 1. Again, this is the position of n, which is n minus 1. Then you put the minus 1, which is that minus 1. And then you are going to get A plus D into n minus 2. You can leave it here. If you want to multiply, you can multiply. If you want to leave it here, you can leave it here. Meaning you can have A plus Dn minus 2D. But it is proper if you leave it here. So that means I can find the second last position here by just writing a 2 here. And then the last position will be A plus D into n minus 1. Then this is Sn. I swap. If I have 3 plus 4, this is the same as 4 plus 3, isn't it? I'm adding everything. That means by swapping, I'm not changing anything. So I'm going to make this equation 1. And then I'm finding equation 2 by swapping what I have here, by swapping it. So I'm going to start with this one, the last term. It is the same as my first term for second equation. And then it's plus A plus D into n minus 2. Plus all the way until this second last one, which was the second first one for the first equation, plus A. Properly. So that means now this is our last term. We've just made the last to be the first to be the last. Imagine you just do this, from there you do this, you swap everything you have here to come this. Once you have this is equation 2. You add the 2. Simple as that. So you say Sn plus Sn. So for equation 1 plus the one for equation 2. And this is going to be everything here. First term adds first term. So it's like A plus D into n minus 1. This is the addition of the first terms. You see, I go to the second terms. Very interesting. I say A plus D plus A plus D into n minus 1. And minus 2, right? Again, I want to simplify this aside so that you can see how it will actually end up. So it becomes A plus D plus A. This is 2A. You see that? You see that? Well, let me simplify it first. Plus D into n minus 2. So A plus A is 2A. D comes here, so it will be plus D into n minus 1 minus 2. I factor out D here, so it will be D into 1 plus n minus 2, and this ends up being n minus 1. You see that? You see that? Because 1 minus 2 is minus 1. So at the end of the day, and when I do the last ones, you see this one and the last one is the same scenario as this one and the first one. So it is going to repeat the same thing until it is as follows. Until it is A plus D into n minus 1. Until it is as follows. Remember when I added this, it became what? It became this 2A plus D into n minus 1. So it will become 2 multiplied, and then there are 2 of them. I get Sn plus Sn is 2Sn. It will become 2Sn equals to this here is the same as 2A plus D into n minus 1. This here is the same thing. This here is the same thing. That means I am having the same thing, many of them. I can simply multiply all of them by n. So if n is 50, that means it's all this multiplied by 50. Because they are repeating themselves. What I mean is this. This plus, here I get the same thing, 2A plus D into n minus 1. I go here, I find the same thing. Until the last one, which is 2A plus D into n minus 1. That means for me to add them all, there are n of them. The total number of this is n. So I'm going to say 2Sn equals to n into 2A plus D into n minus 1. Then I divide both sides by 2. The final answer is Sn equals to n over 2, 2A plus D into n minus 1. You see that? I get 5 marks. Let me prove that one quickly. I see time is up. The trick only, you don't need to copy it, you will find it. You will find it, I will send a picture. Unless if you want to copy it manually. Don't worry. Don't worry. This Sn equals to A into 1 minus r to the power n over 1 minus r. Okay. So they say prove this. So here is the proof. Remember with arithmetic, you do the terms, you swap them, you add the 2, it comes out. But with this one is different. Sn, the first Sn, it is T1 plus T2 plus and so forth until Tn minus 1 plus Tn. Another Tn minus 1 is before the last term, and Tn is the last term. And then I simplify this. You see I'm doing the same thing, but it's a slightly different one. So T1 obviously is A. T2, because of time, I was going to show you the same way I did it in arithmetic. T2, actually, let me show you. T2 becomes A to the power, AR to the power 2 minus 1, which becomes T2 equals to AR. I get this Tn equals to AR to the power n minus 1. We put 2 here. It becomes 2. 2 minus 1 is 1. Then you get T2 as AR. Plus all the way until the last term. The last term, second last term, Tn minus 1 becomes A to the power R, AR to the power n minus 1 minus 1. So it becomes AR to the power n minus 2. Then the very last term will become AR to the power n minus 1. That is making sense. Once you establish this, you are done. For arithmetic, you do not swap it. You multiply by R. So you multiply everything here by R. So I'm going to say RSN. I multiply the left side by R. I multiply everything here by R. It becomes AR plus AR squared plus all the way until AR to the power n minus 1 plus AR to the power n. Because when you multiply this by R, the R adds 1. Again, it will become AR to the power n minus 1 times R. A is the same, R, you write 1 R, n minus 1 plus 1. Then it becomes AR. I mean a to the power n. Okay, apologies, the video had to stop. So just to continue, remember we were just discussing that we are having R to the power of, R as n, and then we multiplied everything by R. That was found in the first equation. So to obtain equation 2, we multiplied everything by R, and then this made equation 2. Then to obtain the equation that says 1 minus R, we are going to play around equation 2 and 1. So for example, if I say equation 1 minus equation 2, it is possible that it will give me R minus n instead of 1 minus R. And then when I interchange, it will give me the other one. So how do you even notice that? Is that you will see with the R. So for example, if you see equation 1, it has Sn. And equation 2, it has R Sn. So by minusing the 2, when I factor out Sn, I'm going to be left with 1 minus R. So this is what we are having up there. We say equation 1 minus. But if I wanted R to start, I was going to say equation 2 minus equation 1. And this will be equation 2, its Sn is R Sn, minus the Sn is just Sn. Then you factor out Sn, it will be Sn into R minus 1. So you see that the difference is very nice and very simple. So just to continue, we are going to continue with this. So we'll be saying equation 1 minus equation 2. And this is giving us Sn minus Rsn is equals to, I'm going to take everything from equation 1, which is A minus AR. So A minus AR plus the other one is AR minus AR squared, AR minus AR squared, and then it continues like that. So this is like term number 1 when I minus it, and then I continue like that until the last one, which will be almost the same thing. It's AR to the power n minus 2 minus AR to the power n minus 1, and then the very last one is AR to the power n minus 1 minus AR to the power n. So one thing we have to notice is here, when they minus, I can factor out R. I can factor out A in everything. So here I can factor out Sn. I'll have Sn equals to the following. So by factoring out Sn, we will be left with 1 minus R. And then we go to the right, we factor out A. So in all of them, they are the same actually, because we factor out A here, we'll be left with A into 1 minus R. And then the thing is, this continues is like A to the power 1, A power 2, A power 3, A power 4, until A power R. It's R to the power 1, R power 2, R power 3, continue until R power n. So what we will do is we are going to plug n minus 1 here, because if you check here, we factor out A, we are left with R to the power minus n minus R to the power n. So when you simplify it all, it's going to end up being something like this. And then you simply divide both sides by 1 minus R, and then it cancels. Then you have proven that Sn equals to A into 1 minus R to the power n minus 1 all over 1 minus R. So remember, if you wanted this one where we are having R minus 1 instead of 1 minus R, simply swap the equations. You minus Rn instead of Sn first. Okay, thank you.